Hello, it's Mr. Cox, coming to you live from Oakview Middle School. We're going to be talking about geologic columns and the geologic time scale.
Okay. um, so we've talked about radiometric dating only being able to be used in certain instances. If there's no radioactive material, then we can't use radiometric dating. And there's got to be a different way for us to go about dating the rock layers. So when we talk about that, we talk about these things called geologic columns, right? And those are basically just pillars of layers of soil that have been dug up in specific orders, right? And these examples are in your book, but they're examples of 3 different areas that may have been dug up at different times. But what they find is when you compare these different digs, is you see this layer has the same fossil and is in the same type of rock as this layer. Okay? And then they also see that these layers are all kind of the same, and the layers below are all the same. And so what they can start to do is they can start putting things in order, right? So they can kind of see that that rock layer was laid down at the same time. Those are trilobites, and that's an index fossil. Remember, index fossils, 4 things to classify them as index fossils. And then the below, right, there's the same material below, the same rock layer below, and then we can see, well, there's green, and then there's the red, and yellow. So what they can do is they can put all of these different so they can make one column of rock from earliest, right, the beginning of time, the beginning of Earth, all the way to present day, right? And they try and fill in those gaps with index fossils and layers, and from all over the world, they've tried to make this column, geologic column of rock layers, when radiometric dating is not possible, okay? All right, so these really begin our notes on the geologic time scale. So this is something that has been put together for many, many years, and many, many scientists have studied it, basically the history of life on this planet. Again, it's theory. We don't know all of these things existed and when they existed, but there's pretty good science that helps support these theories. Okay, so first of all, we have to divide this 4.6 billion years into different times, just like we do our days and our months and our years. So the largest geologic time unit is called the eons, okay? And that's kind of like our years. And then we go down, and eras make up eons. So that's kind of like days make up years. And then periods make up eras, which make up eons. Hours make up days, which make up years. And then the smallest geologic time unit is the epochs, or epoches, however you want to say it. I call them epochs, right? That's kind of the smallest unit, right? So minutes, hours, days, years. Epochs, periods, eras, eons. We need to know those in order, which is the largest, which is the smallest. All right? Come on. This is a picture from your book, and I'm not going to be able to show you the whole thing. It'll do a better job if you look at it in your book, but this is the geologic time scale, okay? At the bottom is early in history, right? At the very bottom is the beginning of Earth's creation, right? And then at the very top is modern day, where we are now, okay? And it separates, right? So here are my eras, here are my periods, here are my epochs. All right, so there you can see that this era, right, the Cenozoic era, has 2 different periods that make it up, and then multiple epochs that make up the different periods, okay? So we're going to dive a little bit further into this. If we start at the very beginning of Earth, right, 4.6 billion years ago, we start at this time called the Precambrian time, or the Precambrian era. There is little information known about this because it happened so long ago. All right, but because of tectonic plate activities, there's very few fossils because the rock layers have been pushed down into the mantle, melted, and any fossilization that has occurred has been melted long ago, right? But realistically, this is a majority, 88% of Earth's history exist in the Precambrian time, which is crazy to think of, right? So out of 100%, 88% of it existed in the Precambrian time, okay? 88%. So that means the other 12% is the rest of history. So this started when Earth began 4.6 billion years ago, and it ended 542 million years ago, right? So 4.6 billion years ago to 542 million years ago. 88% of Earth's history right here, right? At some point during this time, Earth's atmosphere began to form oxygen. So we're not exactly sure when, but at some point, Earth began some sort of oxygen in its atmosphere, right? So some sort of plant life or some sort of organisms began to take the carbon dioxide out of the atmosphere, convert it, and make oxygen. So early in life, we think the first crustal rocks form early. Earth's surface is cool enough for liquid water, so the first unicellular life appears. All of this is theory. We think that's what occurred, and then somewhere along this, right, we're going 4.6 billion or 4,600 million years to 542 million years. We started to get some oxygen in the atmosphere. The first multicellular life appears. The first fungi appear, right? And this is all in this Precambrian era or Precambrian time. And then we see the first shelled organisms such as arthropods and mollusks appear, right? So it's this evolution, right? So we started with unicellular life, and then that unicellular life evolved into multicellular life, and then the multicellular life got even more complex with shelled organisms such as arthropods and mollusks, okay? Not a ton known about this era. So realistically, we don't know a lot about 88% of our Earth's history. We're trying to connect the dots, but it's like shooting in the dark. It's like drawing in the dark. It's very difficult to put together because a lot of pieces are missing, okay? We move on from the Precambrian time to the Paleozoic era. And the Paleozoic era is known as the age of fishes. So as those shelled organisms, the mollusks and the arthropods, started to evolve, some of them evolved into fish. Many bony fish fossils have been found in the rock layers that existed in the Paleozoic era, right? So it's known as the age of fishes because we saw lots of fish fossils. This exists from 542, right, the end of the Precambrian time, to 251 million years ago. So around around 300 million years this era lasts. Okay? Most land masses were separate. Then they collided to form Pangaea. And this is divided into 7 different periods. In the first period of this era, the Cambrian period, an explosion of life is thought to have come from the warm, shallow seas that covered the continents. Okay? So here is kind of the snapshot of the Paleozoic era. Right? First vertebrates appear, and then we got modern oxygen-rich oxygen has formed. First land plants appear. So remember, the theory is everything came out of the water. There was no life on land. It all was in the water originally and then evolved onto land. The first arthropods appear on land. The first amphibians start to appear. The first reptiles begin to appear, and then the formation of Pangaea is complete. So different continents banging together into the one large continent called Pangaea. The Permian mass extinction is a result from the major environmental change. Not sure what exactly that was, but there was a huge change that caused a mass extinction of a lot of organisms, and that ended the Paleozoic era and began the Mesozoic era. Okay? Trilobites, which is an index fossil, existed during this time. Okay, so that's a picture of a trilobite during the early Paleozoic era. Various types of trilobites, such as this fossilized trilobite, flourished in these shallow seas, right? So this was one organism that early in the Cambrian period thrived because of the shallow seas on the continents. Okay, so moving on to the Mesozoic era. Mesozoic era was known as the age of the reptile. Okay, and this is probably one that you're pretty interested in. The age of reptile, right? Conditions on Earth favored them to survive much more than any other organism. So the environment on Earth, reptiles were favored to survive. This exists from the end of the Paleozoic era to the 250 million years ago to 65 million years ago. During this period, or during this era, Pangaea began to break apart. So it was one landmass and it began to break apart. And this is divided into 3 periods. Okay, so if we look at the 3 periods, here's the Triassic period, the Jurassic period, and the Cretaceous period. Okay, and then within these, we've got some kind of snapshot things. Pangaea begins to break apart early. All right, the first mammals begin to appear, and then the first primates, primitive birds, begin to appear. The first flowering plants start to occur here in the Cretaceous period. The first modern birds were thought to have appeared here, and then the last portion, right? What ended this era is the meteor impact theory. The theory that a meteor hit Earth, causing massive clouds of dust that blocked out the sun, that killed all of the dinosaurs, and then gave rise to the next era that we are in. So we are now currently in the Cenozoic era, which is from 65 million years ago to present. All right, and there's a lot that we can tell from these layers of rock, known as the Age of Mammals. So the reptiles, the dinosaurs, and all of those reptiles were not favored to survive, and mammals then became the dominant species or dominant organism that thrived on the planet. Right? Environment drastically cooled, and ice ages and mammals became the dominant species on Earth. So we had many different ice ages, but because of the ice ages, mammals began to become dominant. Specifically during the epoch, the Pleistocene epoch, ice sheets advanced, right? So it got colder, and then they retreated, and it got warmer, and then it got colder, and then it got warmer, and then it got colder. So there were multiple ice ages throughout this epoch, and that bred a very cold climate. So so mammals that could survive in cold climates thrived, like the woolly mammoth. Okay. If we take a look at this, we see that these different epochs that make up this era, most modern mammals, families including whales, carnivores, hoofed animals, and primates have appeared at this point in our history. You've got to remember, this is the end of the dinosaurs, 65 million years ago, and then this is present day. The first grasses appear in the tertiary period. Right? India collides with Asia, and Antarctica drifts over the South Pole. Remember, Pangaea is breaking apart, right? It's moving to its present-day location. The continents are moving to their present-day location. The first hominids, or early human ancestors, appear way over here, right? And modern ice age begins. So the most recent ice age that we have experienced begins roughly about 1.8 million years ago, somewhere around there. And then we get all the way to the end, or the present day, where modern humans appear. Okay? So now, what's crazy to think of is humans have really been around for just a sliver of all of Earth's history. It's crazy to think of. Remember, 88% of Earth's history was spent in the Precambrian time, right? Way early in Earth's history. Now, what causes one end of an era and one beginning of an era? Well, a couple different things, right? So a mass extinction is truly what causes the end of one era and the beginning of another, right? At the end of each era, something occurs that causes an enormous number of species to die quickly, and therefore the era ends. And a new era with abundant new life forms begin, right? So a massive killing of lots of dominant species like the dinosaurs, and that gave rise to the mammals then being better suited for the environment, okay? For example, the last mass extinction 65 million years ago had wiped out the dinosaurs, which occurred during the Cretaceous period, the last period in the Mesozoic era. The impact hypothesis states that most scientists believe a giant meteorite came crashing into Earth and raised a whole bunch of dust, blocked out the sun rays for many years, and therefore killed off a great number of plants and animal species within just a few years. And the rock layer, the geologic column, shows us that. Right? Around the 65 million year mark, there are massive numbers of fossils of these different dinosaurs and different reptiles that then gave breed. Because they died, mammals were then able to thrive and flourish. Okay? So we went over a lot. What I want you to do is kind of revisit the geologic time scale and the different eras, and make sure that you really understand some of the things that we went over on those during those different eras. All right, so we're going to talk more about this. Make sure that you've wrote down 3 or 4 or 5 questions that come up in your mind as you're watching this, so we can have more in-depth conversations the following day. All right, that's it for now. Peace out, homies.